Episode 119. Okay. Hello, everybody, and welcome to episode 119 of I Wish You Were Dead, a podcast about things that used to be alive. My name is Mike, and that is Gavin. And Gavin, how's your face?
You know, it's a little yellower in parts than it was. Maybe a little blacker, a little bluer in certain parts.
It's a real shame.
It is. So, Mike and I had the pleasure of seeing each other in person this past weekend.
It really was a great time.
It really was. So we let's see.
How you gonna handle this?
I don't know. Anyway, usually every summer for the past good number of years, I think even in 2020, some of us got together. One of our friends has a camp up near Old Forge, New York, so in the sort of lower part of the Adirondacks. And every summer, we've tried to get up there as friends and have like one last hurrah before school starts. But now that we're all adults, we're like, I guess summer, because that's when we've always done it.
Or for me, one last hurrah before school starts.
Right. So it was technically after the first week of classes here at Bucknell. But it is what it is. But so we were together. We did sort of a lawn game Olympics. In the past, they've done countries. This year, we decided to change it up and do holidays. Me and our friend Kevin were Labor Day, so I got to dress up like a newsie from the 20s and shout union things. And I printed off fake union cards. And anytime someone complained about like anything, I would walk up and I was like, "Do you need representation in your workplace? Take this union card and present it to your employer." Mike and our friend Nicole were this very real to us, but semi-fake holiday called Easter Wine Wednesday.
How dare you, first off.
Hey, it's very real to me, Mike.
Good.
But anyway, this is just sort of a holiday that some of our friends celebrate together. We're a little short on time this week, or we would explain it. But if you enjoy It's Always Sunny in Philadelphia, let us know on
episode 4.
Yeah, season 5, episode 4, right?
Yep, that's the one.
Yep. So comment on the YouTube version of the podcast, and we'll be happy to explain. But yeah, so some of our other friends were various different holidays, and on the Saturday, we were basically finishing up, and we decided to play one more adult beverage game that involves slapping some cups. And I happened to be next to Mike.
We're next to each other.
Yep.
Never a great place to be.
No. And Mike is a very competitive person. And
one might say.
He slapped the cup, and the follow-through on it was quite strong. And slapped me right in my eye. So
got him pretty clean too.
Yeah, you did. It I will say it's not as bad as I thought it was going to be in the moment. Nobody seemed to have noticed it on Monday. Even though we have our department meetings and I was like around all the other faculty. Maybe it's just a weird thing to be like, "Hey man, what's up with your eye?" Although one of my coworkers who we hang out outside of work too. She was like today she was like, "Do you have a black eye?" I was like, "Yeah." And then I actually was like, we were around a bunch of students, so I didn't want to be like, "Hey, yeah, no, it was definitely during an adult beverage game." And so I was like, "Yeah, we were playing Can Jam, and a stray frisbee caught me." So if you hear this, Lorelai, who's been a guest on the pod before, that's actually what happened. Anywho, I'm sure by tomorrow or the day after, it's going to be more or less gone. But yeah. Always
so weekend.
Yeah, it's never a dull moment when Mike and I are together.
Especially when you include everybody else that was there. It's a raucous time.
Yeah, it sure is.
I'm glad you're doing okay, buddy. Unfortunately, you guys may have noticed, we don't have Fia here today. Fia was working on some stuff. She isn't able to make it, but we've got us. And we are a little bit short on time, so I think we're going to get right into it. Right, Gavin?
I don't know if you have a relatively short today in history. I'd like to hear some history today.
Well, let me tell you what. No, I do not, because I
Okay.
forgot to look it up. So if you
Well,
want, I
that-
can look that up right now. And
that
if we have time at
solves-
the end of the podcast, that'll be the way we end the podcast.
Nope, that answers that question. Then moving on. But before we get into the main meat of the episode, do not forget to rate the show on whatever platform you listen to us on, and make sure to follow us on Twitter. I'll let that hang there. Facebook and YouTube to give us feedback on the show about any future topics that you'd like to hear on the podcast. You can suggest those in those places as well. If you'd like to be a guest on the show, if you're a sciencey person, we have a guest form down in the show notes every week. Next episode topic, well, it's one that ends in a 0, and none of us have talked about it yet, so it may or may not be one of the other two hosts doing it. We'll cross that bridge when we come to it. I don't know what we're doing next episode, so you'll know when we know.
We call that in the business a secret.
Exactly. I believe it's scheduled to be one of Fia's episodes, but I know she has a lot of life stuff going on right now, involving moving from swamp to swamp. So, we'll cross that bridge next episode. So, like I said, when we know, you'll know. But that's all of our housekeeping out of the way. Now, on to this delayed episode about tails. That thing that you're...
We were supposed to do this one our last episode, right?
Yeah, we were. And then I just sort of in the moment decided to be like, hey, let me rant about student loans real quick. So, tails. It's that thing that you see a lot. It's the name of the sidekick for Sonic the Hedgehog. It's what your dog wags at you when you walk into a room. But what is it? And what are some cool tales that exist out there and in the past? So, Mike, if I were to ask you, what is a tail?
A tail. So, let's see here. I am assuming the characteristics of a tail. Does it have to include a bone? The way for any new listeners, the way we do, whenever we're talking about anything new, Gavin will say, hey, Mike, what is this thing? What is a bird? What is a reptile? What is a tail? And I just have to do the best I can as a lay person's explanation.
Right. Mike is basically the surrogate for you all.
Yeah. That's a real nice way to put it.
Oh, thank you.
So it is some sort of appendage that protrudes out of the back of an organism's body that generally involves bones, I think, because I think animals that we think used to have tails and don't anymore, like there's still vestigial bones there for it. So I'm going to say that a tail has to include bones, and it is some sort of appendage that is non-essential for the organism to survive, that protrudes out of the lower back of the body. Because they can be furry, they could be not furry, they could be long, they could be short. So yeah, I don't know if there's any specific descriptors of that besides just I'm going to say they have to have bones, and that's my best guess right now.
Okay, that is debatable whether that last bit's true, whether bones or not is true. We're going to touch on that just a smidge, but this is a very vertebrate biased podcast.
Okay.
So technically, how I couldn't find like a solid description. So this is what I kind of came up with. And this is just in the definition extremely vertebrate centric. So we'll touch on why it's kind of fuzzy here in a little bit. But okay. I would call it part of the spinal column. So it's part of the spine. It's not like some other limb or something like that. So that extends past the sacral vertebrae, which are the vertebrae that are fused to form your hips. And also sort of extends outside the body cavity. So, for example, like in humans, we have the vertebrae. They extend past the sacral vertebrae, but it's not outside of the body. It's still inside, That is sort of the best definition that I could sort of come up with. That kind of falls apart when you look at anything other than tetrapods. So, for example, fish. Well, they don't really have sacral vertebrae. They don't have a pelvis, per se. At least not in the way that, you think of your pelvis. So, the best real example is sort of like vertebrae that extend past the anus. You're going to hear the word anus a lot this episode.
I'm in, and that's all I have to say.
All right. And like I said, very vertebrate heavy definition. If you look up, for example, if you go to the Wikipedia page for tail, one of the first pictures you'll see is of a scorpion. And it's like, yeah, I guess that kind of has a tail. But again, depending on how you define tail, it kind of doesn't, because the tail, quote unquote, of a scorpion is actually part of its body. Like, it has organs and stuff in it.
Okay.
For example, the anus of a scorpion isn't like underneath the tail anywhere. It's basically right before the sort of segment at the end that has the stinger. So it's like that last segment that has a stinger on it is called the telson. It's basically between that and like the jointed segment, next to it. So it's at the anus is at like the very end of the tail, which doesn't seem like it should be called a tail if your butt is all the way out there.
So a tail can include like vital organs. Like it's not just cosmetic or vestigial, depending on the organism.
If you include scorpions in that, yeah. Invertebrates, no, not really.
Okay, so scorpion is like the exception that proves the rule here.
Right, and there are some other things like, for example, like lobsters or whatever. They again, arguably you could call that a tail, but they've got like a bunch of legs and stuff under there.
Right.
No, I'm sorry. That's where their gills are. That's my mistake. So it's like that has vital organs. They really need gills. So it's like, but again, arguably that is or is not a tail. For the rest of this episode, we're going to be referring almost exclusively to vertebrates. So for vertebrates, no vital organs, but to say that they're not vital for the organism being alive isn't quite true, and we'll get to the reasons why.
Okay, let's do it. So this is going to be a tails, essentially just vertebrate tails this episode.
Right, and so much so to the point where one of the defining features of a chordate, so that is sort of the, taxonomic group above vertebrate, so it includes vertebrates and a couple of our weird cousins. One of the defining characteristics is a post-anal tail, at least ancestrally. So if you look at like the very early stages of a human embryo, humans do have a tail then that extends past the anus. But in humans and, many other animals that have lost their tail, it just doesn't develop into adulthood. So tails, almost without exception, are mainly used to help an animal move around. It's mostly used for locomotion, whether directly or indirectly. However, we'll cross that bridge when we come to it. Let's talk about some of just the cool things that a lot of animals do with their tails, other than simply just using it to like swim, for example.
Okay.
Tails can vary wildly in their size and shape and length. So, for example, the longest tail of any land animal, because whales have very big tails, but of any land animal belongs to a giraffe, which kind of makes sense. They're just really tall. So it's about 3 feet long. So basically an arm or more of tail.
Jeez, okay.
However, the longest tail relative to like the total length belongs to the Asian grass lizard, whose body is about 3 inches long, but the tail is about 9 inches long. So its tail is 3 times the length of its body.
That feels like almost it should be a different thing if it's that big. Like,
no, and it's go ahead.
No, it's like that. That's not like a well thought out thing. It's just like, wow. When I think of tail, I think of something that is a reasonable size,
not 3/4 of the length of the animal.
Yeah, like that seems right. Like at that point, it feels like we're talking about a different thing.
Yeah, and I tried to look up, sort of hypotheses why it's that long in this particular species, and I couldn't really find much. Um, as we'll talk about, a lot of lizards in particular use their tail sort of in defense for multiple different in multiple different ways, but we'll talk about that a little bit. However, most lizards in general have tails that are at least the length of their body. So it's for a lizard, it is unusual to have less than 50% of the total length be tail.
You said it's unusual for that?
Yes.
Okay.
However, the reason I specified lizards is that contrary to what it might look like, snakes have quite short tails.
Oh, what? Hold on. Snakes have tails?
They do, because
a snake is all tail. What?
No,
right,
it's mostly chest. That's like 90% of a snake is like chest equivalent, basically. So they have tails because they have vertebrae that extend past the anus. That's the definition we're working with here. And so snakes generally, it's usually only about 10% of the total body length. This can vary a bit, but that's generally the length. I know in many species of snakes that are often kept as pets, for example, males, I think, tend to have longer tails for some reason. I'm not quite sure why that tends to be a general trend in snakes, but yeah, something else. But it's like, that even in the males where it's longer, it's not like it's, half the body length like it is in lizards. Many groups of animals have also lost their tails, such as we humans and our sort of ape-like relatives. Birds, for the most part, have lost their tails. We'll quibble a little bit on that in a little bit.
Okay.
And then also frogs and toads, at least as adults. As tadpoles, they still have tails. But as adults, they lose it. They break it down to form the rest of their body as they're going through their weird metamorphosis. And so that's, for the most part, kind of the only like large groups of animals that have like totally lost a tail. There are some that have it really short, like for example, hippos have quite short tails. Pigs have a very reduced tail, but
does like a pig or a hippo does that serve a purpose?
Not particularly. Hippos use it to spray their poop. Like when they poop, they wiggle their tail back and forth really fast, and that might be a thing so that they don't, because they're so aquatic, so that they don't just poop in the water, at least in such a concentrated place. I think I've heard that, but I have no scientific reference for ever if that's actually true.
Not a hippo expert here.
No, not at all. But in general, if you're not using it for anything, it benefits you to not have to spend energy maintaining it,
Right. That's if something is vestigial, best to just get rid of it. So, but in general, if animals at one point had a tail, they probably continued to have that tail.
Yes, by and large, yeah.
Okay.
As I mentioned before, some tails or some animals have tails that they use for defense. For example, many lizards use their tails like whips, particularly iguanas and many of the larger monitor lizards, like Nile monitors, Komodo dragons, stuff like that. And I have seen people who have scars and have gotten stitches from being cut open by like their pet iguana whipping them with their tail. Yeah, iguanas, PSA, do not ever get a pet iguana. They are bad pets. They're not friendly. They take up a ton of space. They're bad. Don't get an iguana. And they'll cut you open with literally every part of their body: their claws, their teeth, and also their tail.
My uncle had iguanas at one point, and then there were no more iguanas, and I'm not sure what happened, but I can imagine that he didn't like that.
Yeah, no. They're also just, especially green iguanas, are just generally mean. They do not. You have to work with them a lot in order to get them to like you or even tolerate you. Um, much more famously, though, many smaller lizards can detach their tail to distract a predator while the actual lizard scurries away. They can just chop their own tail off.
Uh, That's always wild seeing like videos of animals that can just lose parts of their body, and it's like, oh no, I'm fine. Just
Oh yeah. So, for
incredible.
example, I have a leopard gecko, which is a ground-dwelling gecko, not the kind you see like sticking to walls and stuff. But they store a lot of fat in their tail. However, all geckos, especially, but also many other kinds of lizards, have like a particular joint between some of their tail vertebrae. So it's not like it just like breaks like a normal bone break, or just kind of randomly. They have a specific joint that it breaks at, and they can just like twitch some muscles and just pops right off.
Mhm.
And in most of them, it will grow back. For example, if my gecko, if I scared her particularly one day and she decided to pop off her tail, it would take a solid couple months, but it would grow back.
Well, can we at one point do an episode on why humans can't do that? Why we can't regenerate?
So there are limits to that, even in lizards, because even in the species that do grow their tails back, there are some geckos, like I know, like crested geckos, which are the kind that can like cling to glass and stuff. They can pop their tail off, but it will not grow back. And even in leopard geckos like mine, if it does pop its tail off, when it grows back, it will not be the same. It will be like shorter and stumpier, so it won't just be like a brand new tail. And also, it won't regrow the bone. That will just be like hard, much stiffer cartilage. So it won't be like as useful of a tail, but it will grow back.
Okay.
Let's see. I learned this. Some species of rat can do something vaguely similar, in that they can purposefully detach a couple layers of skin on their tail. So it's not detaching the whole tail, but they can just choose to like, I believe the term was degloving, like you're taking off a glove. But in this case, the glove is a couple layers of skin.
Yep, that's a word.
Yep.
For
so
that. Okay.
so rats can do that. If something grabs them by the tail, they can just choose to sever a couple layers of skin and just sort of slide right out of the new little skin tube and run away. I learned that, and now you do too. You had to too.
Yep. All right, moving on.
Let's see. Others sort of, most of these lizards, especially the whipping ones, will sort of do that as a warning. They don't want to do that, because even like iguanas can detach their tail. And if they whip their tail just right, they can snap it in a way that makes it break off. But so they'll try to bluff doing that at first, like as a warning. Many, particularly snakes, have this behavior as well, where they use their tail to let predators know, hey, I'm here, don't mess with me. The most famous ones being rattlesnakes, where they developed an entire new organ at their tail to tell predators, or just like a horse walking by or a human, hey, I'm here. I want you to know I'm here. Please don't eat me. I'm spicy. However, this behavior of just like shaking your tail as a snake is found all over the snake family tree, even in snakes that are not venomous. However, in this particular part of the world, copperhead snakes will do this. They'll shake their tail really quickly to try and shake leaf litter, and basically use like a fake rattle made out of the leaves in the forest around it where it lives. So this is very widespread behavior.
Okay.
Some others, again, we're still sticking in like lizards and reptiles and stuff, use their tail to sort of disguise their head. There is a species from Australia called the shingleback skink, whose tail is sort of short and stubby and round, and basically the exact same shape as its head. So it's sort of been hypothesized that this is sort of to try to get a predator to attack the tail, which is much less important than the head.
The tail's less important. I mean, that makes sense. The tail being less important than the head.
Right. If a predator grabs the tail,
Right.
I think I didn't actually look it up. I think this species is one of the ones that can just pop its tail off. But regardless, if a dingo bites your tail, you at least have a better chance of getting away than if it bites your head.
Mm-hmm.
See,
Yeah. Right. That makes sense.
Well, and while we're still sort of on the note of defense, some
Right.
fish have barbs on their tails that they use for defense. Famously, stingrays have a venomous barb on their tail that they will whip around to try and defend themselves. Rest in peace, Steve Irwin.
Pour one out.
Some animals use their tail directly to catch their prey, so now sort of no longer defensive, but sort of offensive, if you will. There's a group of sharks called thresher sharks, where sort of, if you imagine a shark or just any generic fish tail, how it's sort of the two lobes, like the top one and the bottom one.
Mm-hmm.
The top one is extremely long, about the same length as the entire rest of the body. And it will use this tail like a whip, and it will whip fish, which stuns them, and then it just leisurely swims up to them and eats them.
And I assume this all happens like so fast that the fish don't even know what's happening.
Right. Yeah. But yeah, and this isn't just like one species. There's a whole group of these guys. I think there's somewhere like more than 3, but less than 10, somewhere around there.
Okay.
There's also my personal favorite, because when I learned about this, I freaked out, and I'm like, there's no way that's real. But there is a species of snake called the spider-tailed viper. So this is a snake that at the end of its tail has a lure that is brightly colored and has scales that protrude off the sides of it that look like the legs of a spider. And so this is like a bright pink color, while the rest of its body is sort of a brown rocky color, and it uses this lure to attract birds that it then ambushes and eats.
Wow. I mean, that's intense. So basically what I'm gathering from the podcast so far is that while the function of tails can be very diverse, it is just flat wrong to say that they are vestigial or cosmetic. Like, tails can serve a wide variety of functions in different animals.
Yeah, absolutely.
So is it weird, now that I'm saying that out loud, is it strange to have this one thing that we all agree is a tail, but serves so many different functions in different animals? Like, is that unusual, I guess, where we've got this one body part that exists across different species that we call the same thing, but serves just so many different functions, and not all of them are the same in different species. Is that unusual?
Not at all. Look at
Okay.
hands. The hand of a person versus the hand of a dog versus the flipper of a turtle or a whale, or anatomically we all call it the same thing because they have the same evolutionary origin. That's what we in the business call homology. That, parts that look different but came from the same evolutionary feature. They're called homologous. And so that's not at all unusual. Or even just look at teeth, for example, as well. There's a huge number of body parts that we could, talk about in the same vein as tails.
Okay, so that's something that's not unusual. That is a common feature of evolution.
Yeah.
Okay.
All right, a couple more non-locomotion examples here. In many birds, tail feathers, so not necessarily the tail itself, but tail feathers are used for display. Famously, such as in turkeys, where they have the big sort of fan, or much more famously in peacocks, where the tail feathers actually hamper its other, potentially life-saving things like flying. Uh, where male peacocks and, to an extent, male turkeys can fly less well because they are so ostentatious and big, have these big tails that they use to show off to the ladies.
Mm-hmm.
In many animals, and I'm sure if you have dogs or cats, you've experienced this too, many animals will signal their mood by moving their tail in different ways. Sort of, dogs being happy and wagging their tail, or when they're scared or sad, they'll tuck their tail between their legs. Cats, we recently got a kitten. When he is, playful or angry, he'll swish his tail, back and forth really quickly. White-tailed deer here in North America will raise their tail and show that bright white fur that gives them their name when they feel alarmed. And that's sort of to show, everybody else around, all its deer friends, hey, I'm a little spooked. Everybody, keep your eyes out. And my last bullet here for just, like I said, non-locomotion things is that in some colder climates, generally things have smaller tails to help conserve body heat. But in some animals like Arctic foxes, they have big bushy tails that they use to sort of curl around themselves when they sleep and sort of use it as like a blanket almost to help conserve heat while they're sleeping. Yeah.
Fascinating. Okay, so there's way more going on here than I ever would have thought.
Yeah, absolutely. And this is just scratching the surface of, the different uses of tails. However, as I've mentioned a couple times, locomotion is what the absolute vast majority of tails are used for. Most notably, fish. Because give or take, half of all vertebrate species are fish. And with very few exceptions, that's how fish move. There are a couple of exceptions. Things like rays, like stingrays, manta rays, they use their pectoral fins. Things like flounders or other flatfish, they still use their tail, but they also use their other fins. Seahorses use their dorsal fin, so the one that's like on their back that you think of like a shark coming up through the water, that same fin, that's how they move around. They just use their tail to wrap around seaweed and stuff. And then the various species of ocean sunfish, or mola mola, which are giant and have a very reduced tail, but have these gigantic dorsal and I think they're anal fins that they use to move around with. So, but again, that's like at most a couple thousand species, maybe, compared to, the other 30,000 species of fish. Even most land animals will use their tails to help them swim. For example, crocodilians, that's how they swim. They don't even use their legs at all while they're swimming. They'll just tuck them up against the body and use their tail. Many larger lizards, like iguanas or monitor lizards, will do the exact same thing. Tuck the legs against the body and swim like a crocodile. Let's see, things like salamanders. They don't generally have webbed feet or anything, so when they're in the water, they just use their tail. Sea snakes, even though, like I said, snakes don't have long tails, but in sea snakes, they have like a fin, or I guess a fluke, because it's like fleshy, is technically the term for it, that they use.
Snakes having tails is still
just
wild to me. I'm Googling this right now as you're talking. Do snakes have tails?
They sure do.
The answer is yes. Damn it. Okay.
And then also famously the aquatic mammals, so things like whales, manatees, even beavers and otters and things like that still use their tails mainly to swim. So that's just all the aquatic ones, and that is the vast majority of life, of vertebrate life, lives in the water. But the ones on land still use their tail for locomotion, but they had to get a little more creative about it. Most generally use it for balance while they're running around. For example, things like squirrels or monkeys that sort of, run or jump through trees. If you've ever seen a squirrel make a pretty big jump, they'll sort of move their tail around like a helicopter. Mostly just to sort of,
Yeah.
they'll do that to sort of control better how they're landing and keep, make it so their body doesn't twist around and stuff. Sort of like a human, if you're like trying to balance, you wave your arms around. Same thing, but they have tails to do that instead. Things like cheetahs or other, fast-running things with long tails like that, mostly cats, use it to counterbalance while making turns while running. If you've ever seen a cheetah chase something, or if you happen to look up a video of it right now, keep an eye on the tail. It will be moving around wildly as the cheetah tries to, chase down an antelope or something, because it has to make all these turns. One of my favorites are kangaroos, because they use their tail in a large variety of ways. Firstly, kangaroos are, most famous for moving around as hopping. And when they do that, they just use their tails as like a big counterbalance to like the upper body. But because kangaroos are so specialized at hopping, they actually have lost the ability to move their legs independently of one another anymore.
Okay, so is that why it's a little bit awkward sometimes seeing them like hop around?
Right, high speed, they're great at. They are extremely
Right.
efficient at like high speed, long distance hopping. However, they're kind of clumsy when they're going a little slower because they can't move their feet separately from one another and sort of walk like a normal animal does. So what they do is they will put their arms on the ground and their tail on the ground and use their tail as like a fifth leg. And so they'll move the legs forward and then move the arms and tail forward. And sort of, so they are functionally five-limbed when they're moving around, slowly, like grazing.
Damn. Okay.
Yeah, kangaroos are really cool. Some animals, mostly that live in trees, have prehensile tails. So specifically things like New World monkeys or chameleons or the opossum. They have tails that you can just sort of wrap your arm around.
What do you mean that they can wrap their tails around their arms?
No, that was me misspeaking because my earbuds were beeping at me. So they
Okay.
can wrap their tail around things like tree branches. So it's actually like it's a grabby tail.
Oh, so like in my head, I don't know if this is like a lemur like swinging from a tree or something.
So not lemurs. Lemurs can't do that. So
Like
that is
what else can?
just New World monkeys. So like squirrel monkeys, capuchin monkeys, stuff like that.
Mm-hmm.
Lemurs can't do that.
Right. Okay.
And not even like other monkeys in places like Africa or Asia, they can't do that either. Just the monkeys from Central and South America. But yeah, so they also, like kangaroos, have functionally a fifth, limb when they're running around doing stuff in their environment.
That wow. So they have a fifth limb, but like two of those limbs are. I don't want to say they should only count as one, but like they are in tandem with each other.
In kangaroos, yeah, but not
Okay.
monkeys. Monkeys and stuff, they can fully move their legs
Right.
however they want.
Right. Of course. Yeah. Okay.
And then lastly, again, talking about locomotion here, birds, the ones that don't have these giant ostentatious tails or tail feathers, they use their tail feathers like a rudder, sort of just like the tail end of a plane. They use that to sort of help steer while they're flying. So, as at the beginning, you had mentioned the tail not being particularly necessary for an animal to survive. And I would argue that, getting around in your environment is the only way to survive.
Oh, yeah, that's an important one.
Yeah. So, while it's not, it doesn't contain any vital organs per se. Again, there are some potential exceptions to that. You could argue that, like that spider-tailed viper, that is a vital organ because that's how it gets its food. You could argue kangaroos, in addition to their tail being, so big and vascular, they are some of the only animals to have very specialized blood vessels in their tail, so that helps with like their circulation a bit. So that potentially you could argue, they wouldn't be as successful if their tail didn't have some of these potential vital organs. But that's all just sort of the variety of that's a very small slice of the variety of modern tails we have today. But this is a paleontology podcast. So let's talk about some tails in the past. And where did tails even come from anyway? Because like I said, this is mainly a vertebrate thing. And even among things like arthropods, so this would be your insects, crustaceans, things like that, they're not particularly common. There are things at the ends of their bodies, things like bee stingers, for example, but it's not like a tail because that's full of organs. That's just a part of the body. So let's talk about where tails come from. So the first chordates, that is, again, sort of the larger group that includes vertebrates, appear probably in the Ediacaran period, but we don't see them for the first time in the fossil record until during the Cambrian period. So this is all sort of in the ballpark of between 500 and 600 million years ago.
And that's when we first start seeing tails.
More or less, yeah.
Okay.
So with some of the things around sort of at the farther end, around the 600 million years ago mark, some things, most of the life that we're seeing, at least like large multicellular life that we're seeing at this time, it's like we have no idea even like, are you an animal? Or are you some other weird kind of life that's like animal adjacent? It's like, well,
such as
things that just aren't around anymore.
Is there an example of something that is animal adjacent, but
not anymore?
Like this is
not today. Are you asking me for like a genus name of something around back then? Or
I mean, I'm not going to know the name of the gene, but like a description of like, and maybe this can be a whole other podcast. Like I'm trying to conceptualize something that is animal adjacent, but not an animal, and I'm getting a 404 right around that one.
So it's mostly just things that like we can tell you're not a plant or like an algae because you're mostly like bilaterally symmetrical. So like your left side looks more or less like your right side. We can tell that like you move around, but like we can't tell if it's like related to anything we have today or whether it's way off on its own very early branching thing before technical animals came around.
Okay.
And this is so early.
Have a whole podcast episode dedicated to this.
Yeah. And
because this is not like the focus of what you're trying to talk about. I couldn't let that one go without being like, huh?
Right. But and the tricky part is that we don't really know how they got there. We don't have any things majorly before them to help sort of guide us. So they just kind of show up. At least as far as the fossil record is concerned. And so the first chordates, again, somewhere in here, but mostly during the Cambrian period. So somewhere between, 500 and 550 million years ago, somewhere in that ballpark. And these first chordates look very similar to a group of animals that are around today called lancelets. If you haven't heard of them, don't at all feel bad. They're a very weird group of animals. So I'm going to try to describe them, but it really is kind of just best if you just Google it. For this one, I know this is an audio medium, but they're vaguely eel-shaped. Just sort of long, slender, and kind of tapered at both ends. They have, a lack of any noticeable fins that you would see on a fish. So if you think of like a tuna, where it's got the pectoral fins on the side, the little dorsal fin, and the tail fins like that, none of that's there. So basically just imagine of almost like a cigar shape, but just kind of more pointy at the ends.
Okay, sure.
They don't have eyes or anything that really says that the front is a head, including a brain. They don't technically have a brain.
Jeez.
Yep, they
Okay.
just have nerve cells that kind of go around the whole body, but they don't have like a centralized brain per se. They don't, like I said, have fins like a fish. They don't have scales like a fish, but they do have a mouth that's vaguely at the front of their body, and an anus at the back that has a tail behind it. And that's why they're chordates.
I have nothing to add on that.
Yep.
Okay.
These tails at the, like I said, at the very end of the body do have like a little tail fluke at the end. So sort of like a fin at the end to help them swim. And that's basically what the earliest chordates look like. Just an elongated, little pointy cigar with like a little tail fins looking thing at one end. And so that's the earliest thing that we have around, of our most distant relatives.
Mm-hmm.
And throughout the whole early history of vertebrates, so this is, getting into when things started looking more like fish. Their tails continue to be mainly used for locomotion, just like they are in most fish today. Although it is kind of hard to tell whether there were any particular weirdos that might have been doing something different, because for the early history of vertebrates, for the most part, we don't have the tails, because the heads we have a lot of heads, because in two groups in particular called the ostracoderms and the placoderms, they have extremely heavily armored skulls made out of like actual bone, but the entire rest of the body is mostly made out of cartilage in terms of their skeleton. So bone preserves way better than cartilage does. So
Right.
we know a lot about what their skulls were looking like and what the front of their bodies were looking like, but the rest of the body, we do have some fossils that preserve it, and for the most part, they just look like sort of like a more naked fishtail. They weren't necessarily as lobed as a fishtail tends to be, but generally looking like a normal, more like an eel, I guess, than other kinds of fish. But so in this early part, no real weird stuff going on.
Okay.
And so things kind of start to heat up in as far as tails are concerned when vertebrates start to come up onto land. As I'm very biased, I'm not at all a fish person, so I tend to agree.
Yeah.
The first salamander-like animals that came up onto land had to do something with their fishy tails, because by this point, fish had a much more fish-looking tail, where it has all these extra lobes and fins coming off around it. But up on land, those things get in the way. So
Right.
they kind of just made the tail a little longer and pointier and dropped all the fins, and that's kind of how you got a salamander-like tail. More or less.
Right.
And so all of these early things, they needed the salamander-like tail because they were still hanging around in and around the water a lot, but the extra fins and stuff just like would likely get broken on things up on land, or might make it easier for another thing to grab you up on land, and because it's not helping you while you're on land, that was just a selection pressure to try to get rid of those extra fins if you didn't need them. So when all of this time period was happening, this was sort of in the late Devonian period, so sometime around 360 to 380 million years ago or so. And then fast forward close to 100 million years of tails mostly looking like a generic lizard tail. Nothing major going on in terms of all these tails. So we're fast forwarding to the Permian and Triassic periods, and you get some larger predators and things like Dimetrodon, which is very famous. It's the sort of short, squat, reptile-looking animal that has a big sail on its back, as well as other sort of crocodilian cousins, such as Postosuchus, that had relatively long tails that were likely used to help balance while they were chasing prey, very much like I mentioned earlier with things like cheetahs. However, many of the herbivorous, particularly synapsids, so that would be things sort of on the mammal side of the vertebrates, They all had relatively short tails. Not quite sure why, but that was just a trend that I kind of noticed looking through, just the general family tree of early mammal and mammal relatives. They all have generally really short tails, and I'm not quite sure why.
Do we know much about like the purpose these tails are serving at this time?
Generally, no. Um, it could be a variety of things of just like, well, my ancestors still had it, so I still have it.
Mm-hmm.
It could be this was generally a really hot time period, so there may have been, they might have been using that in a way to like dissipate heat in some way. They might have had some things on it that that we can't really see as fossils, but might have helped like brush insects away. That's another use for tails of things like horses and cows use it a lot for that in their herds.
Mm-hmm.
So there are other things that the fossils might not be able to tell us that they might have been using it for, but we don't really know. But nothing super flashy at this point. Like I said, just kind of look like general, no spikes, nothing crazy on them yet at this point. Although a quick side note for a group of reptiles called the Drepanosaurs, which we've talked about a couple of times on the podcast from the Triassic period, who basically had a claw at the end of their tail.
I assume that's like, for hunting to be a predator.
Nope, as far as I know, they were insectivorous or herbivorous. They were relatively
Is it for
small.
self-defense?
We don't know.
Jeez. Okay.
It was thought at first that it was like, well, maybe they're it was for climbing, helping to climb. Maybe it was like an early way of being sort of prehensile. But these days we kind of think that they're burrowers. So it wouldn't really help with that. So yeah. Not really sure. Just had this kind of big old claw looking thing at the end of the tail. However, these two time periods, while we do have a lot of fossils from them, there are definitely notable gaps in time where we don't have a lot of fossils. So I'm sure that there are some other cool weirdos during this time period, but I couldn't really find too many.
Okay.
Now we get to the Jurassic and Cretaceous periods, and this is where tails really start to cook. There are a few groups of dinosaurs in particular that are really well known for things with their tails. The first ones are the ones that come to pretty much everybody's mind when you think of tail fanciness and dinosaurs, which are a group of dinosaurs called the Thyreophorans, or as most people probably know them, the Stegosaurs, like Stegosaurus, and the Ankylosaurs, like Ankylosaurus. Stegosaurs, in general, had very spiky tails, as in Stegosaurus having 4 3-foot long spikes at the end of its tail, and there's very little question what that was used for.
Yeah. Mm-hmm.
That was definitely some kind of defense weapon, or potentially like interspecific combat, like males fighting for mates and things like that. But
that's one of those things I would love to be able to see. Like, we have videos of different animals, fighting like that, like dinosaurs fighting with it. Like, that would be a sight.
Yeah, absolutely. And especially it's, if you watch a lot of particularly older, from like the 50s and 60s movies and things with dinosaurs in them, you'll see that they have their tails sort of whipping around like a cat's tail almost, which we now know was not really the case. Their tails were much, much more stiff.
Mm-hmm.
And so with these guys in particular, their bodies were also very long and like sort of very like narrow, but very tall, like their body cavity. And so they would have to like look over their shoulder to use this weapon, which just seems very ineffective because then you can't see where you're going. So we don't really know how it was used per se, especially because to my knowledge, we don't have like any predator fossils that show like obvious marks of being hit by one of these. Which, the fossil record does miss a lot of stuff. just, how the fossil record is.
Right.
But this time period in particular, we have a ton of good fossils from, the late, mid-late Jurassic. We have a ton of fossils. So if this was something that was happening regularly, I think we probably would have found it by now. I don't know for sure that we don't have, these scar fossils, but I don't at least know of any. So that is the one group of the thyreophorans. The other one, the ankylosaurs, are sort of the armored tank-like dinosaurs that often had clubs at the end of their tails instead of spikes.
I assume that's also a combat feature.
Yes. And this one we for sure have, we definitely have fossils of like broken shins and things from predators. That's like, well,
That's awesome.
Ankylosaurus is in its environment, so it could have tripped on something, or it could also have been from this tail club. This one, I believe we for sure also do have like members of the same species that have, signs of being hit by some of these clubs, so they use it to fight one another as well.
Damn.
Yeah. So those are the two that are sort of most famous for their tail weaponry, especially. But sauropods also have a wide assortment of things going on with their tails. So sauropods being the large, long-necked dinosaurs. Several species had some kind of, much smaller, but some kind of club-like thing at the end of their tail. So it's not as big or as, robust as something like an ankylosaur club.
Right.
But some of them definitely would use it, most likely probably on each other, because it didn't seem like it would be all that effective. But also, it's just a handful of species and we don't know a ton about them. So who knows? Most sauropods, though, had much longer, very whip-like tails. And so it has been hypothesized that they would either use it to whip enemies or, predators. However, it seems like they were too fragile, at least at the end, for that. Like you'd hit something and it'd like instantly shatter your tail. It's also in certain species like Diplodocus, which is a very famous one from the Jurassic period, thought that it might have used it to break the sound barrier and make like a loud bullwhip sound to scare off predators.
Good God, that's incredible.
Or potentially to communicate with one another from long distances.
I mean, I would ask, do we know what that communication would entail? I assume no, it's just like hypothesized.
Yeah, of course.
This is theoretically possible.
Right. And I think that there have been some structural analyses done that sort of question whether or not it could have broken the sound barrier like a bullwhip does. So all to say, we don't, there's a lot of very well educated ideas. But with dinosaurs, a lot of times it's like, we don't have anything functionally like them in the ecosystem today. We have no idea what this thing was doing with its life. So, sauropods especially, we don't really know what a lot of them were doing with their tails. Presumably, they were using them for some kind of defense in some form. Also, mostly just because for some of these really, really big ones, like Diplodocus was very large. Even if you didn't hit him with the end of the tail to whip him, you're still hitting him with a tree. So that's still not going to feel great.
Yeah, it doesn't, right. It almost doesn't quite matter what it is at that point.
Right, and it's like, that's not an exaggeration. Like their tail likely was like as, thick as a tree trunk. So if you can...
Thick with a couple C's here.
Yeah, absolutely. And then lastly, for dinosaurs here, theropods. Most notably for their feathers. So theropods being the, mostly two-legged walking around, meat-eating dinosaurs. Everything that birds do with their feathers, in terms of like display or using them to cover their eggs and things like that. Theropod dinosaurs were almost certainly doing all of those things as well. They were, I'm sure, brightly colored. I'm sure some of them have done funny dances and stuff, waving their tail feathers around and things like that to communicate with one another. That almost certainly happened.
Mm-hmm.
And then lastly, while we're still in the Mesozoic period here, some mammals. Because mammals often get overlooked during this time period, but we have some fossils of mammals that, for example, there's an aquatic species that had a very beaver-like tail that it was using to swim. Our, primate ancestors and likely some like rodent ancestors as well had tails that helped them climb around in trees. I don't think I saw any evidence for like prehensile tails, but I'm sure they were doing things like squirrels, waving them around as they were leaping from tree to tree and stuff like that, just generally helping them balance as well. So then lastly, as we're going through time, getting to the Cenozoic, so that's sort of our relatively recent, since the dinosaurs went extinct, time periods.
Right.
And the big notable players here are whales, obviously. They are the largest animals to ever live, and the only way that they're able to move their giant bodies are with their tails, which they have decided to just say, hey, legs, who needs those? I'm just going to, make this big fin at the end of my tail and travel the world with it. Very, very similarly, Sirenians, which are your manatees and dugongs, took the same approach. They also, on a much smaller scale, but they said, I don't need legs anymore. I'm just going to turn my tail into this paddle and travel the swamps with it. Not quite the world, but the swamps.
Right.
Well, I guess
Shout out for you.
dugong. Yes, shout out for you. Dugongs tend to get into more deeper water than manatees do, but so those are sort of the main mammal ones that I haven't talked about too in depth in the beginning part of the section. But if you were to look up pretty much anything about mammal tails in sort of extinct species, the main things you'll look up is this group called the Glyptodonts. And if you've seen the movie Ice Age, which I know Mike has, the guys with the shells,
yep,
the big sort of Volkswagen Beetle looking shells,
yeah,
those are Glyptodonts. They are relatives.
How accurate are they in the movie?
From like an anatomy standpoint, no, not bad.
Okay.
But so they're related to things like armadillos. I think those are the closest living relatives, but also things like sloths, anteaters, stuff like that. And these guys are the only instance that I was ever able to really find of mammals having tail weapons, like dinosaurs did.
Mm-hmm.
So some of them sort of just had like an armored, spiky cone of bone sort of around their tail just to sort of add to the defense of, like their giant dome shell. But others had just like sort of a combination of the stegosaurs and the ankylosaurs. They had a big spiky club. So not just the spikes, not just the club, but both. At the end of their tails, they would use for defense.
That's nuts.
And I believe also we have found evidence that they used it on each other as well. So, it could have been for predator defense, or it also could have been mainly for beating each other to say, hey, get away from my lady. Or potential. I don't know if there was any sexual dimorphism with this either, whether males had it and females didn't, or it could have been the ladies being like, hey, get away from me. I still have my kid. And then lastly, a quick note about some turtles. We haven't mentioned turtles, I think, at all in this episode so far. Turtles generally have, no
little stubby tail, right?
Yeah, in general, some like snapping turtles have a quite long tail, actually. And just for reference, never pick up a snapping turtle by its tail, or any turtle. That is like connected to the shell, and you'll probably break its tail. Just a little PSA. But there was a group of turtles in the southern hemisphere, I think just South America and sort of Australia and some surrounding islands are over there. called the Myelaniids. And there's, I think, 4 genera, but they are famous for having also very clubby tails. And some of them survived, particularly on Australia, up until just like a couple thousand years ago. So like we were so close to living in a world where there are tails with, weapon attachments to them. But, these days, short of just like the things whipping tails and stuff like that, there are really no tail weapons on anything, whether it's mammal or reptile or stuff like that around today, which is a little unusual.
That's a loss.
Yeah, it is a loss. And both with these turtles and the glyptodonts, we only missed those by like a couple thousand years. And I think there might even be some evidence of like the very earliest Australians to arrive on the island of Australia might have interacted with them a little bit, but I don't know. I don't remember exactly the timing for that. So, but yeah, that is a very brief history of the long part at the end of most animals.
And that, I mean, it is, tails are one of those things, like at the beginning of this episode, where everybody can kind of know it when they see it, but it is interesting to think about, like, what are tails and all the different uses the tails actually have. I learned quite a bit in this episode I guess part of it is stuff that I may have already known, but like thinking about them all together as one thing.
Right,
like,
yeah.
Yep, those are all tails. Like, yeah, it just kind of changes your, I don't know, perspective on the whole thing.
Yeah, absolutely.
So really quick, now that we are at the end of the episode, 2 things that happened on August 30th in history. One good, one bad. They are tangentially related to each other here. Starting with the bad one, 1957. Gavin, can you name any senators from 1957?
1957. My first guess is Strom Thurmond, but I think that might even...
Strom Thurmond.
Was it really? Okay, I thought that might have been a little before his time, but I know he was in the Senate forever.
Yeah, there was also like other guys there, but so in 1957, Strom Thurmond, noted racist,
yes,
gave the longest filibuster in Senate history against one of, not like the famous Civil Rights Act, but a Civil Rights Act. Spoke for over 24 hours, which, like, I hate Strom Thurmond, but it's like, all right, you got to give it up to him. That's a long time to speak. However, a couple years after, in 1967, so a decade after that, Thurgood Marshall was confirmed as the first black justice to ever serve on the Supreme Court.
Wow. It's a little poetic justice there.
I hope so. And then Strom Thurmond would continue serving on the court for like another 40 years.
Yeah.
He was around forever. But that was our Today in History, and that was episode number 119 of I Wish You Were Dead, a podcast about things that used to be alive. We'll be back in 2 weeks, but until then, take care, everybody.